Hello guys, welcome back to class. In this session, we'll start with another set of operators. What are the operators we have seen in the previous sessions? What are the operators we discussed in the previous sessions, guys? We're done with arithmetic operators and string concatenation, right? Arithmetic and string concatenation completed. Very good. Now we'll start with assignment operators. Most important, all operators most important, all topics most important. I'll say most important common word. It means every topic you have to study. Then only you will be called as an expert. Assignment operators. In assignment, again, you have two types of assignment operators. One is simple assignment operator, which is just equals, is a simple assignment. And second one is compound assignment operators. In compound assignment, you have plus equals, minus equals, star equals, division equals, and percentage equals. There are 5 compound assignment operators. For your 5 arithmetic operators, 5 assignment operators are there. So previously we have studied the arithmetic operator plus, arithmetic operator minus, and we are going to study the assignment, simple assignment operator equals. Equals is different. Remember this carefully. Equals is different, plus is different, and plus equals is different. See, there is no space between plus and equals. Without a space, this is called a single operator. This is combination of 2 operators. It looks, but it is single operator. Goal is different. Right? So we'll start learning these operators one by one. Start with the simple assignment operator. Simple assignment operator equals. Equals is the simple assignment operator. So how you write this? We're going to write it as operand 1 equals to operand 2. Operand 1 equals to operand 2. So it means whether it is a unary operator or binary operator or ternary operator. What kind of operator it is? How many operands required, guys? How many operands required? 2 operands, right? Clearly, I have written on the screen. Operand 1, operand 2. You need 2 operands. 2 means by, 1 means unary, 2 means binary, 3 means ternary, right? So 2 operands required. 2 operands required. So we'll call it as binary operator. Okay. What is the purpose of this? What's the purpose of this operator? Assignment. Assigning operand 2 to operand 1. That's a key goal. So whenever you learn operators, we discussed in the previous session, set of things you have to learn. First, you learn about purpose. What is the purpose of this operator? Purpose is assignment. Next, whether it is unary or binary, how many operands required? 2 operands required. Next, what types allowed? What types allowed? What types allowed also we have to study, right? Tell me what type is allowed. Here any type allowed, right? Means operand 1, operand 2 can be any type. Any type allowed. But condition is the types you write must be same or compatible. Same or, this is very, very important point. I'll explore this with multiple examples. Any type allowed, but must be same or compatible. Okay, so this about this, we'll end this next. So what should be the operand 1? What should be the operand 1? Operand 1, always the variable. Operand 1 must be always the variable. Why operand 1 is the variable? For example, can I write like this? Can I write like this? 10 equals to 20. Is this okay? 10 equals to 20. Is this okay? It is not okay. Why not okay? You are assigning 20 to 10. We can't do that. You are assigning some value, means you have to assign to a variable only. So left side operand. This operand 1 is the left side operand. Left side operand must be a variable. Then what about right side operand? Right side operand can be a value. Right side operand can be a variable. Right side operand can be an expression. Right side operand can be a method call also. There are various options we have. Right side operand, that is operand 2, can be a value, can be a variable, can be an expression, can be a method call. We have 4 options on the right side. See the examples. Anyway, we understand this is not allowed, right? Next. A equals to 10. A equals to 10. Is this okay? Left side variable, right side a value. Directly value 10 I am assigning. So, okay. Next, B. A equals to B. A equals to B. B is a variable. Fine. Left side must be a variable. So, A is the left side. Fine. Right side, value, first case, value okay. Second case, variable okay. Next, C. A equals to B plus C by 2 into 25. What is this? This is an expression, right? You can have an expression also on the right side. You can have an expression also on the right side. So the expression will be evaluated. Final result of an expression will be assigned to the variable A. So right side expression also allowed. And D, for example, A equals to, I am calling a method called sum. We'll talk more about methods if you don't have much idea, but some basic idea you may have. Sum is a method. I'm calling a method. So method will be executed. Method may return the value. Whatever the return value coming from the method, that I'm assigning to the. So what I'm doing? Last case, calling a method. Method return value I am assigning to the variable A. Case expression I am writing. Expression will be evaluated and the result of expression will be assigned to the variable. Okay. Here I am writing B. Value of B will be assigned to the A. Here directly value. Value I am assigning to the variable. These all 4 cases are okay. And if you observe, finally you are assigning a value only, right? So this is, you are assigning a value, directly assigning a value. And here value of variable, correct? And third case, value of expression. And fourth case, return value of a method. So final story, if you observe, finally you are assigning a value into the variable. Clear? That is the assignment. That is the assignment. So is that clear? It is a binary operator which is used to assign the value to a variable, and any type is allowed, but types must be same or compatible. And left side operand must be a variable always, and right side operand can be a value, can be a variable, can be an expression, can be a method. But finally, value of a variable or a value of an expression or return value of a method, anything, value only you are assigning to the variable. Now, we'll try to understand any type is allowed and types must be same or compatible. For example, take the scenario 1. So, first case, I am writing a equals to 10. Is this valid or not? You declare the variable also best. Int a equals to 10. And second, int b equals to a. I'll write the expressions, you tell me which is valid and which is invalid. Double d equals to a. Next. Int x equals to true. Okay. Next. Boolean b equals to 99. So these cases I have. Start with the first case. Int a equals to a. So your types anything allowed, but must be same or compatible, we are telling. So 10 is an integer, a is an integer. So both the operands are of same type, correct? Both the operands are of same type. So it is allowed. Second one, a is an integer, b is an integer. For assignment, left side one operand, right side one operand you are taking. Those two must be same. Must be same or compatible. Second one, tell me valid or invalid. I'm asking second one. You come one by one. We'll talk one by one, guys. Second one, valid or invalid? Second one, why invalid? Naveen. Naveen, why second one invalid? All are telling valid, only Naveen told invalid. A is integer, yes or no? A is integer, B also integer. A is integer, B is integer. So both are of same type, right? Both are of same type means allowed, guys. Allowed. Next, third one. Third one, D is a double and A is a small integer. So these are allowed or not allowed? This is actually okay. The point is here, not same. These are not same, correct? Not same, but compatible. Not same, but compatible. So what is the rule we have to discuss? Same must be same or compatible. Compatible means, remember compatibility means always smaller can be assigned to higher. Among the number types, we have a 6 number types. In the number types, there is a compatibility. 6 number types, there is a compatibility. Smaller numbers can be assigned to bigger numbers always, compatible. Double and integer not same, but compatible. So compatible means allowed. Compatible means allowed. And this one, fourth one, not same, right? One side, x is integer, true is a boolean. You are assigning boolean to integer. So data types boolean, integer, not same. Not same and not compatible. Am I right, guys? Not same and not compatible also. Not compatible also. So not compatible means fourth is not allowed. Not same, not compatible, we can't do assignment at all. Next, fifth one. Fifth one also not same and not compatible. Not same, not compatible. We can't do any assignment. We can't do any assignment explicitly. So is that clear about this point? What is the meaning of all types allowed? You write anything. The variables you declare here, left side, it can be an integer, double, boolean, anything, byte, whatever you want to declare. But the right side must be same or compatible. Same or compatible. That point is clear? So we'll do more exercise on this compatibility. We'll do more exercise in the compatibility. Go to the next page. So the most commonly used literals in any program. What are the commonly used literals we have? One is the numeric literals. Numeric literals. And second is Boolean literals. Boolean I am representing separately intentionally. And one more type of literal we have is string literal. Right? What are the numeric literals we have? What are the numeric literals we have, guys? Byte, short, int, long, float, double, plus char also comes under numeric literal. Boolean literal means only Boolean is there. String literal means only string type is the string literal. Now what we have to see is, among this numeric literal, there are 6 numbers plus 1 character. Whatever I represented in one box, the numeric literals in this box are compatible. Do you understand the point? The numeric literals in this box are compatible. Is that point clear? Numeric literals in that box, all the numeric literals, one number is compatible with other number. Okay. Next, Booleans, one category, strings, another category. So there is a conversion mechanism. Here, number 2, you can start with number 2, string, number 1, string to number is the number 2 conversion, and number 2 Boolean is number 3, Boolean to string is number 4, Boolean to number. Number 5, Boolean to string, string to Boolean. There are 6 types of cases we have to study. 6 type of cases we have to study here, guys. Now, each one you tell me one by one. I'll write here and you answer it. As per the numbering I given, I'll write here. Number 1. What's the number 1? Num to string. Number 2. String to num. Num is number. Shortly I'm writing. Number 3, as per diagram, num to Boolean. Num to Boolean. Number 4, Boolean to num. Number 5, as per this, Boolean to string. And 6th case, string to Boolean. All 6 cases clear? And before discussing this, can you tell any of these are compatible as of your knowledge discussed so far? We discussed so far so many things. As of the knowledge, as of the points we discussed till now, as of the knowledge you have, any of these are compatible? Any of the 6 cases are compatible, guys? Any one at least compatible? Is there any one case which is compatible? Is there any one case which is compatible? No. Very good, guys. Very good. There's no compatible case at all. See the case. String I am assigning to number. String assigning to number means where you should have a left side, what should be there, right side, what should be there for assignment operator. String to number. Which one I have to take? String right side to number. To number means left side. Means int x equals to string JLC. Can I do this? Next. Num to string. String str equals to 99. Num to boolean. Boolean this side. Boolean x equals to 99. And num to boolean. Boolean to num. Int x equals to true. Boolean to string. String str equals to true. And string to boolean. Boolean x equals to string to boolean. Yes, JLC. And all these cases are. Now we are talking about Pavani is telling that first one num2 string may be okay, but see guys, see Pavani, see guys, we are talking about assignment operator, right? According to assignment operator, which are compatible, which are not compatible. These are all not compatible. You write a program, you test it, you write these 6 lines in the program. When you write the 6 lines, you will get a 6 errors. These are all not compatible. It means, very important note here, very, very important note, direct assignment of these types not allowed. But there is a way to convert from one type to another type. So there is a typecasting mechanism. We'll talk about that later. This note you keep the same diagram what I represented here. Again, I'll draw this after some days in a different topic. We will learn. For example, you have a number. You want to convert directly. I can't assign a number to string. But there is a mechanism to convert number to string using some functionality. You can convert number to string. You can convert a boolean to string. You can convert a byte to string. Similarly, string to number. Like this, if these conversions are somehow possible using indirect approach, but directly string cannot be assigned to integer. Integer directly cannot be assigned to string. So whatever the statements are, 6 statements here, these 6 statements are directly not allowed. But there is a way to do the conversion. You can do the conversion of this one type to another type. Somehow that we will discuss later. But as we are talking about assignment operator, direct assignment is not at all possible. Compiler will not accept that. Is that point clear, guys? Is that point clear? Very good. Now, based on the knowledge we gained, we'll start working on the basic labs now. So what you learn now, you have to apply in the labs. So we are doing part 2, right? Part 3. 89th lab completed previously. Okay. Lab number 89 completed. So we'll do this as lab 90. Okay. So first is a simple. Int a equals to 1, 2, 3. So can I assign in this both are same type or different types? For assignment, two operands required, right? Two operands required, and these two must be same or compatible. These are the key points we studied. And uh, first operand 1 must be a variable. Operand 1 must be a variable. Operand 2 can be a value or a variable or expression or MC, method call. Okay, these are the key summary. We done it. So according to that, tell me a equals to 1, 2, 3. So what do you have in the left side? Variable. Okay. Right side value. Okay. Both are same or compatible? Both are same or not same? Both are same only. Both are same means allowed. Okay, allowed, no problem. And next I am writing one more as 12 plus a. B equals to 12 plus a. Now you tell me right side I am writing expression. Is that okay? Right side expression okay? Yes, okay. And these are same or not same? How you will check same or not same? How you will check same or not same? B is integer. Okay. What is the right side? Right side you are writing expression. When you write an expression, you have to first you have to evaluate the expression. Final result of the expression type you have to consider. Integer plus integer. The result is integer. Yeah, integer plus integer result is integer. So right side integer, left side integer. Both are same. So this case is both are same types I've taken. So I think it has to compile successfully and gives the output for us. Java C lab 90.java. Okay. 123 and 12 added. Fine. Done. Simple. Next. 91.java. Okay. So I'm just commenting this all code. If required, otherwise I'll take out this. I'm writing 10 equals to 20. You know, I think what happens when I write 10 equals to 20. I think both are same type only. Both are same or not same, guys? Why not same? See, 10 is integer, right? 10 is integer. 20 also integer. Both are same only. Can I do this? Can I do this? Why no, Shravani? Yeah, same type rule, okay. But we have another rule. Another rule that left side operand must be a variable, right? Left side operand must be a variable. But you are not using left side variable. You are using a 10 value, which is not allowed. Compiler has to scold us. Compile it. Read the error. Unexpected type. Compiler is telling unexpected type. What is unexpected? It is putting the arrow in the 10 symbol, 10 number, it is putting arrow. Unexpected type. Required. What is required? Variable. Found. What is found? Value. Type is not the problem here. Type is not the problem. Even though if you mention the type, it will give the same. So what it is telling? Read the error message. Unexpected type. Prakash. Required, telling is clearly left side, what is required? Variable is required. What is found? Value is found. So telling not allowed this. Not allowed this. Okay, keep that as it is. Or just we understand this is not allowed. Next, int a equals to 10 less than 20. What about this? I think this time left side I'm using variable only, guys. Left side I'm using variable only. Left side I'm using variable only. It seems okay. Is that okay? No, right? Because left side you're using variable. That rule you passed, but you have to pass another rule also. Data types of both the operands must be same or compatible. Now, left side integer is there. Right side you have an expression. So in the expression, you can't consider 10 is there, 20 is there. So 10, 20 integer only, both same. We can't say like that. Your expression can have anything. It is immutable for me. What is the final result of an expression? Final result of an expression coming as a Boolean. 10 less than operator means it will tell yes or no. You are asking 10 less than 20. It will tell yes or no, true or false. So Boolean, integer, compatible or not compatible? These are not at all compatible. You see in the big diagram, not compatible. So it has to give an error. Is that incompatible error? Incompatible error, guys. Incompatible types. Boolean cannot be converted to integer. Incompatible types. Boolean cannot be converted to integer. Okay. Next one more I am doing. Into b equals to 99L. Now tell me long C equals to 123.456. I think same problem, right? Not same and not compatible also. In the compatible case, smaller to higher is compatible. When higher to smaller assignment is there, which is not compatible. Possible lossy conversion from long to int. Very good. In this case, possible lossy conversion from double to long, right? And understand the error message framing, how they framed error messages. See, in the case of Boolean and integer, they are clearly telling Boolean cannot be converted to integer. Clearly mentioning cannot be converted. So no way, leave that. But in the case of number to number, those are actually compatible. I told number to number, all numbers in one group, they are compatible. But here currently telling as incompatible because higher to lower, it is telling the error message is smooth, right? Not harsh, like cannot be converted. It is telling okay, but possible lossy conversion from long to int is a kind of message they are giving is. If you do long to int conversion, higher to lower conversion, there is a chance of losing the data. It means conversion is possible, right? Conversion possible or not? These are compatible only. Same here, double and long are number types in the same number family. Here also incompatible currently telling because of higher to lower you're assigning, but a smooth error message, there is a possible loss of data in this conversion. Please have a look. But Boolean case, you don't do any actions when class is going on. Right. So these are the incompatible cases, but incompatible, there are two versions. Purely not compatible, not convertible, and second is whenever among the number types, when you assign higher to lower, there is a possible loss of data. So that also mentioning as incompatible. So both the cases, it is giving as error. Right? Now, how to correct these errors? When you're writing the program, this is important for us. When you're doing such kind of statements, what we have to do carefully. So we know that when you write a Boolean expression, we'll get a Boolean value. So the what variable are declared here? The variable are declared as Boolean only. Okay. Next, you are assigning a long value. When assigning a long value, we know that that should be assigned in a long variable. And your value is a double value. Your value is a double value. So the variable you are declared as double only. So these are the basic things you have to learn from this. Now this program will compile successfully and gives us the output. 92 has to compile and run successfully. This is 92, right? Compile and giving whatever the results we are getting it is showing the results, right? Now, basic rules we understand. Next, in the case of number to number, in the case of number to string, not compatible, we cannot convert. Number to Boolean, we can't convert. Number to string, number Boolean to string, like 6 cases we discussed as shown in the diagram. These cases, right? These direct assignments not possible. Direct assignments not possible. But there is a special methods to do this that we will discuss in later sessions. Now the point to take here is among the number types, I told among the number types that these are compatible. But we seen the error just now. In the number types also we are getting incompatible. How to solve that? Do you understand the problem? Go to the next page. When I assign the statement here like this, int x equals to 99L. This is a long number only, integer, number only. Number means I told as a compatible. Or if I take this as a long x equals to number 99. This is also number and long. Now when I write these two statements, whether both are valid, in which of these are valid, guys? Int x equals to 99L and long x equals 99. I have two statements, 1 and 2. Which is valid, which is not valid? Only second one is valid. Hari, you are right. This is, you are assigning number to number only. But we discussed that smaller to higher is compatible. Automatically it is doing. So this will not give error. This works. But this is giving error. Whenever you assign higher to lower, it is giving error. But whenever I assign lower to higher, it is giving error. It is taking okay. What is happening here? What is happening here? Why it is giving error? Why it is giving okay? Why it is giving error? Because these are numbers only. This is because of typecasting process. Typecasting process. Typecasting. Understand, most important topic. We'll use this throughout Java. Everywhere we need this. What is a typecasting? Any idea? Typecasting is a process of converting one data type to another data type. Process of converting one data type to another data type is called as typecasting. Conversion to one type to another is called as typecasting. There are two types of typecasting, guys. There are two types of typecasting. One is implicit casting and second is explicit casting. Implicit casting and explicit casting. Implicit means automatic conversion. Implicit casting means automatic conversion. Explicitly means you have to do conversion. You have to do conversion explicitly. If you do conversion, that is explicit. When automatically happening, that is the implicit. It means in both the cases, conversion happening, right? In both the cases, conversion happening. Yes or no? Was the typecasting we discussed? What the definition? Convert one type to another. When you convert one type to another, that is called as typecasting. Now, either it happens automatically or you do the conversion. Now, what you have to learn, when conversion happening automatically, when we have to do explicitly. Take this story. For example, I have byte b equals to 99. A byte variable, valid statement. Can I do this int a equals to b, guys? Can I do int a equals to b? Whether statement is valid, you see this statement mainly. Whether this statement is valid or not. Int a equals to b. You are telling valid. How it is valid? My question to you is, byte is different, int is different, then how those are same? Just now we discussed that in the assignment operator, when you use assignment operator, the operand 2, operand 3, operand 1 must be same or compatible. Same, not same, but compatible. But here what is happening is, implicit casting is happening, guys. Pankaj, this is valid because implicit casting is happening. It means when you assign, remember this, when you assign lower to higher than automatic conversion happens. This is called as implicit casting, automatic casting. Is that clear? This is called as implicit casting or automatic. Lower to higher, higher to lower also compatible only, Pavani. Higher to lower also compatible. Lower to higher also compatible actually. But in the case of lower to higher, automatic conversion happening. In the case of lower to higher, automatic conversion happening. You no need to worry about the conversion. Automatically, some kind of conversion mechanism is happening so that b is a byte. You are assigning byte to integer. B is different, byte is different, integer is different. But internally, your byte is converted to int and assigned to int. But second case you take. I am taking reverse of this. Int a equals to 99. So I am writing as byte b equals to a. What happens here? The statement is valid or not valid? Byte b equals to a. Higher to lower. Not valid, right? Means why not valid is automatic conversion not happening. Why automatic conversion not happening? When you have a small value, smaller value, you can keep that in a lot of big space. For example, in the previous case, byte means there is a 1 byte of space. 1 byte of space, I have a data. In this, data is there. Can I keep this in a large space? Small value, can I keep in a bigger space? Any loss of data is there? I have a data in a 1 byte of space. Can I keep this data safely in large space of 4 bytes integer? Yes, no problem. But in the case of integer to byte, I have a data in the integer. Integer means I have 4 bytes. This is a 1 byte, 2 bytes, 3 bytes, 4 bytes. I have a 4 bytes of data in the integer. I have a 4 bytes of data in the integer. Can I store this in a 1 byte? You can't do that. When you do, there is a loss of data or not? There is a loss of data or not? You can't accommodate all. 4 bytes of data, I can't put in a small. Definitely you lose the data. There is a loss of data, right? That is the error message they are giving. When you assign higher to lower, possible lossy conversion from higher to lower. That's what it is telling in compatible. That's what it is not doing automatic conversion. Automatic conversion. But you know that if you feel no problem, I want to do the conversion forcefully, yes, you can do the conversion, you can do the typecasting called as explicit. What you do is byte b equals to, use this syntax of parenthesis a. What is a here? Integer. You tell that explicitly, I want to convert this integer to byte. So in the parenthesis, you write a byte. You write a byte. So your integer forcefully will be converted to byte type, and then converted byte can be assigned to byte. So in these two things happening. In this two things happening, guys. This is valid. In this, what are two things happening? Your number integer is converted to byte, and your byte is assigned to byte. Byte can be assigned to byte, no problem. Previously, integer you are assigning, but now integer I am converting to byte and then assigning byte to byte. So that this conversion is, so this is the explicit conversion, guys. Explicit casting. So tell me what is explicit casting? When you assign higher to lower, higher type to lower type, then you have to do conversion. You have to do conversion. This conversion, what you do is called as, this is called as explicit conversion. This is called as explicit conversion. So do you understand the typecasting mechanism? When you assign a byte to integer, why it is not giving error? Because of automatic conversion. When you're assigning into to byte, why it is giving error? It is not doing conversion, that's what giving error. If you want forcefully, yes, you can convert forcefully and you do the typecasting. That's how you do the typecasting. This is typecasting syntax. So is that clear about typecasting? Any doubts, guys? Is that clear or any doubts? Clear? Vishnupriya, is that clear? Right. Next, similar mechanism we'll study in a different perspective. So now heading I am keeping as a conversion. Calling as conversion. Syntax we'll study, Pavitra, again. We'll study the syntax again. We'll elaborate that once again. See this concept also. Again, I'll tell you about the syntax. Now, syntax will practice more scenarios. Conversion is there. Conversion, how many types of conversions are there? This again two types. One is the widening and narrowing. What is the general meaning of this widening and narrowing? Widening, narrowing. What is the widening, guys? Widening. Widen means you are expanding. Hari, you're right. Widening means expanding, increasing, right? Increasing. So, increasing means which conversion? Higher to lower conversion or lower to higher to conversion? Higher to lower is widening or lower to higher is widening? Where you are increasing? Very good. Very good. Hari, Monica, Pushpa, Pavani. Very good. So, what is the widening now? Definition of widening. Widening means lower to higher conversion. Lower to higher conversion is the widening. Next, is this safe or unsafe? Is this safe or unsafe? This is a safe conversion. Any loss of data in this? No chance. The 2 points. Now write the same 2 points this side also. What is narrowing? Narrowing means you are reducing. Reducing means higher to lower conversion is called as narrowing. Higher to lower conversion is called as narrowing. Is that a safe, guys? No, this is unsafe operation. Unsafe conversion. I'll show you the demo with an example. Why it is unsafe? Practically, I'll show you. But you can visualize, right? I have data in a big space. Lot of space data is there. When you're moving to small, you have a big room, guys. In a big room, you have a lot of books available. In big room, you have 100 books. Now you have a small room. Can you accommodate all 100 books in a small room? You can't do that. Only some you can. That's what unsafe. This is unsafe operation. Now, coming to this. Again, widening can be done in implicit way. Implicit casting can be done. Explicit casting can be done. Narrowing also again. Implicit casting. Explicit casting. Okay. You know implicit casting and explicit casting. Start with the widening. Widening. Widening means lower to higher. In the lower to higher, implicit casting happening or not happening? In the lower to higher, implicit casting happening or not, guys? Lower means first I am taking byte B equals to 10. Byte B equals to 10. So I am writing int A equals to B. Is this widening or not? It is a widening. In the case of widening, means lower to higher. In the case of widening, lower to higher, implicit casting is happening. So this is okay. This happens, right? Done. No worries. But in the case of widening, is it required to do explicit casting? In the case of widening, is it required to do explicit casting? In the case of widening, is it required explicit casting? Anyway, implicit happening, right? Is it required? Is it required? No. Can I do? Can I do? Yes. It is not required. Anyway, automatically happening. But I want to do. Yes, you do it, which is not required, even though you can do it. It means you see the story. Byte, integer, right? You have int a equals to your b. What is the b actually? What is the b actually? Byte. But do you want to convert a byte to integer explicitly? See, Pavitra, you asked a question previously. We'll see the syntax now. Byte, you want to assign to integer. So assume directly not possible. So I want to convert byte to int. So what I had to write in this parenthesis? You write the integer. So your byte, you are explicitly converting to integer and then assigning to integer. Byte, you are explicitly converting to integer and then assigning to integer. Is it required really? No, but still okay. This is, you can do it, but I am saying not required. Not allowed, say allowed, but not required. Very difference is there in that. Is it required? No, not required. Can I do it? Yes, you can do, no problem. No objection from compiler. Fine. In the case of narrowing eyes, come back to the narrowing. In the case of narrowing, I think higher to lower. Explicit casting is required, right? Explicit casting is required. So explicit casting is required. Do that. So I'm taking the higher, my integer a equals to 10. And if I assign byte b equals to a, it gives the error, right? So I do conversion. Byte b equals to typecasting syntax and a. A is integer. What is the destination type? What's the destination type? Where you want to convert? You want to convert to 2 byte. So in the bracket, what I had to write? You write the byte. So now this is okay. This is directly okay, right? Now in the narrowing, my biggest question to you, all of you guys, in the case of narrowing, higher to lower conversion, in the case of narrowing, higher to lower conversion, any chance for the implicit? Any chance for implicit in the case of narrowing? Mostly no, but there are some special cases. I'll tell you those cases. Note. We'll fill this after some time. Note. There are some special cases. There are some special cases where implicit casting is happening in the case of narrowing. Not all the cases. Not all the cases. Only special cases. Implicit casting is happening. Implicit casting is happening. There are special cases where implicit casting is happening. In the case of narrowing, I'll show you all those special cases with various examples later. So this box, examples of the implicit and the narrowing, we'll talk later. We'll come back and fill these cases. Okay. So is that clear, guys? Conversion is of 2 types. Widening and narrowing. Widening means converting lower to higher is called as a lower to higher conversion is called as widening, which is safe conversion because no loss of data. Widening can be done implicitly and explicitly also. Widening case, implicit happening automatically, implicit happening for you freely. But if you want to do explicit, yes, you can do it, no problem. In the case of narrowing, explicit has to happen in all the cases. But there are some special cases where implicit casting has happened in the case of narrowing. Generally, higher to lower, implicit casting should not happen. But they have internally some cases I recognized where implicit casting has happened in the case of narrowing. So is that clear, whatever you have on the board? Points are clear, guys? So tell me, clear or not? Okay, let's start the labs on this. So what's the lab we have done previously? Which lab is completed? We'll go to the labs first. Where is that? Yeah. Lab number 92 completed. Okay, start with the 93. No. By seeing this lab, you tell me which casting happening here. Byte B equals to 10. Any casting happening in this line? Any casting is happening in this line, guys? No, very good. 10 is purely a byte here because whenever you assign a value to the byte, if it is in the range, it will be considered as a byte only, byte to byte, no conversion. Very good. Next. Short S equals to B. Any conversion happening here? What is that? Two answers I want. Whether it is a widening or narrowing, your answer should be like this. Widening, narrowing. If widening means in that, implicit or explicit. If narrowing means implicit or explicit. Your answer should be like this. You tell us either implicit, widening implicit or widening explicit or narrowing implicit or narrowing explicit. So what is the short S equals to B? What is that? Widening implicit. Am I right? Widening implicit. Very good. Very good. Next. Next, guys. Into A equals to S. Into A equals to S. Widening implicit because it is a lower to higher. Widening implicit. Next. Long X equals to A. Same. Widening implicit. Widening implicit. B, S, A, X. Okay. One more I'll take. Double D equals to X. D is the higher or which is the higher? D and long. Test for you. D and long and double, guys. Which is the higher? Double is the higher. Very good. And between long and float, which is the higher? Long and float. Long and float. Very good. Oh, not long, Pavani. Float. Float only. Float only. Float only. Yes, Vishnupriya, Pavitra, Alekya, Lakshmi. Right. I given you the hierarchy of that. I shown you somewhere like this. One diagram like this is there in booklet. Every piece of information, int higher than int is, before to that short is there, right? Short byte. Byte higher is short. Short higher is int. Int higher is long. Long higher is the float. Float higher is the double. This is in terms of compatibility, not in terms of sizes. Size is long 8 bytes, float 4 bytes only. This is the hierarchy in terms of compatibility. Okay? Wonderful. Come back. So I think in all of these cases, in all of these cases, It is widening and implicit. Am I right? Widening and implicit. So widening implicit means we are happy. We don't do anything. I think 93 will compile and run successfully. Am I right? Okay. Compile this. $93. Very good. Same 10 value we done here and there. Okay, done. Next, we'll go to 94. We'll try it on the narrowing now. We'll try the narrowing case. I have int a equals to 65. So in this line, anything happening, guys? Int a equals to 65. It is nothing. Now, char ch equals to a. Char ch equals to a. Byte b equals to a. So what is this process char ch equals to a? Is it a widening or narrowing? It is a narrowing. And byte b equals to a is a narrowing. But are you any casting happening in these two lines? Any casting happening in these two lines? Any casting happening in these two lines? No, as of now, no, right? Assume whether a compiler is doing any casting. Automatic means compiler only will do that, right? Whether a compiler is doing any casting internally, automatic casting happening in these two lines? No. Are you doing any casting? Are you doing any casting in these two lines? Currently, you are not doing any casting. You are not doing any casting and automatic casting not happening, then error will come, right? They have to produce two errors. Similarly, I'll take one more use case. FLO8. Float f equals to 123.45, semicolon. Int c equals to f. Float means I have to assign f at the end, right? Yeah, float int c equals to this. I'll print this to values. F is not specified, I missed it. Now in this case, yeah, given. So in this case, float f equals to 123.45 f. This line is okay. Next, int c equals to f. Int c equals to f. Float to integer, higher to lower. So it is a narrowing. It is a narrowing. And you are not doing any casting. Implicit casting will not happen. So error has to come. So if I compile this program, how many errors you are expecting? How many errors, guys? 4 or 3 only? 3 only actually. Yeah, 3 only. Compile this. Lab number 94. 3 errors. Incompatible types. Possible lossy conversion from int to char. Lossy conversion will come only when you try to convert from number to number only. Within the number family, if you convert one type to another type, then it will give an error called incompatible types. Possible lossy conversion from one to another. But if you convert from other families, string to number, number to boolean, boolean to string, others means it will tell cannot be converted to that so and so. Okay? Done. 3 errors. So how to correct this? You have to do typecasting. Right? Narrowing case, you do explicit casting. You have to do explicit casting in the case of narrowing. How to do explicit casting now? Say char ch equals to a is there. A is integer, right? A is integer. A is integer. Where you want to assign to this? Where you want to assign? You want to assign to char. So directly I am unable to assign into to char. So what I have to do? Convert into to char and then assign char to char. So in the bracket, what I have to write? Char. Very good. Next. Byte b equals to, directly I can't assign integer for this. My A is integer. Now where you want to assign this? I want to assign A to byte. Directly I can't do. What I have to do? Then you convert into to byte. Then assign byte to byte. So in the bracket, what I have to write now? Byte, you write. Next, I have int c equals to, in bracket, f I am writing. F is a float higher. So I am trying to assign my integer to float, but it is not allowing, float to integer. What I have to do? Convert float to integer. Then you can assign integer to integer happily without any trouble. So in the bracket, what I have to write? Your destination type you have to write. Integer. You see? This is the left side, whatever you write is the destination, guys. In the bracket, you always write the destination type. Char, you want to char, assign to char, so write the char. Here you want to assign to byte, write the byte. You want to assign to integer, write the integer. So typecasting is clear. Explicit typecasting is clear. Syntax is clear. So do the three changes in our program. Here I have to write the char. So this line is okay. Here I have to write the byte. This line is okay. Here I had to write the int. This line is. So 3 errors are corrected now. 94 now has to be in. Now in this we have to explicit casting. This line you say now, what is this line? These are the 3 lines. This line, and this line. These are the narrowing and explicit casting now. Correct? Narrowing and explicit casting. Very good. Now you compile, it will compile and do. There may be a chance of loss of data. It may happen. But currently, I think when you're doing this, you should make sure that loss of data will not be there. In that case only, you do explicit casting. 94, I am recompiling. Now compiled successfully, and after doing typecasting, it gives the output whatever we wanted. So see, loss of data case, my float value is 123.45. But when I am assigning to integer, your decimal fraction will go out. Integer will not hold the decimal values, right? So the .45 you lost. You lost the data, right? Loss of data happening. So when to do explicit casting? If you are really okay for a data loss, if you are really okay for a data loss, then only do the explicit casting in the case of narrowing. It means that .45 gone, no problem, guys. It is not important to me currently. 45 is not, decimal fraction is not a matter for me. Let it to go. In that case, then only do that. If the .45 decimal fraction is most important, then don't do this kind of conversions. Is that clear? If, when you're developing application, if data loss is okay for you, no problem. That will not damage big. In that case only do, otherwise don't do the conversions. Okay, guys, is that clear? Next lab, 95. Okay, 95. Int A equals to 300. Question from Harishankar. Loss of data in char from int to. There no loss of data. Hari. I'll show you your example also. I'll show you. See here. This also similar example I designed to demonstrate the loss of data. Okay, what Hari is telling is int a equals to 65 are given, guys. Okay, int you want to convert it to char. Char ch equals to directly I can't write a. So do the explicit casting required. Do it. You cast to char and a. Now, in this line, tell me, in this piece of code, tell me, any loss of data is there? Any loss of data is there in this? No loss of data. Why no loss of data? See the internal story. See the internal story. When you declare a variable, how many bytes of data will be allocated? A variable, how many bytes of data will be allocated, guys? 4 bytes. Very good. I am representing 4 bytes here, see. This is the 4 bytes of data allocated. This is the byte 1, byte 2, byte 3, and byte 4. Okay. In that you are storing 65. For 65, how many bytes required? How many bytes will be utilized internally for 65? How many bytes will be utilized in the case of 65? How many bytes will be utilized in the case of 65? Only 1 byte is more than enough. It means remaining are zeros only, right? Byte 1 is all zeros, all zeros, all zeros. We may not use this. Okay. 65 means how much? 65 means how much? Tell me the binary representation of 65, guys. I think 64. For your easiness, I'll write this. 1, 2, 4, 8, 16, 32, 64, 128, 256. 8 bits, 8 bits I am showing. Tell me the value of 64. 64 means I think 65 means 64 and 1 is 65. Remaining 0, 0, 0, 1, 0, 0, 0, 0, 0. Is that a 64? Right? So this is the 4 byte representation of A. You're typecasting to CH. For a CH, how many bytes will be allocated? Char, how many bytes? 2 bytes only. This is the byte 1 and byte 2. So when you're typecasting and assigning, what happens, guys? The whatever data in A will come to CH. Now here in this byte, all zeros are there. These all zeros. If the all zeros, if you lose also, no problem. These all zeros, if you lose also, no problem. Here this section, all zeros are there. These all zeros will be copied here, right? This contains all zeros. All zeros will be copied here. And the original number will come as it is 001, 000, 001. Your data is coming copied or not? Your data is copied or not, guys? You have integer of big room is there, integer 4 bytes of big room is there, but data is in the 1 byte only. So 1 byte I can, even if I convert this to byte also, any loss of data? If I convert this to byte also, guys, byte B equals to byte of A. Same A65 I am converting to byte type. B I am declaring. B I got only 1 room. Even when I move this also, my data is there as it is. No loss of data in this case also. So when you do higher to lower, they are not telling, read the error message, what they framed. What is the error message? Possible loss of data. They are not telling you will lose the data. No, always you won't lose the data. Possible loss of data. Right? There is a chance to lose the data. In some cases, not all the cases. So clear, Hari? Now see my example, 95. 95 also similar case I told. I want to show the data loss now. Same, leave it. Clearing, this point is clear. You take the 95 lab, which I typed on this. I have a guys. A is 300. Okay. A means how many bytes? Again, the 4 bytes. So this is consider 1 byte small I am taking, 1 byte small I am taking. Byte 1, all zeros, right? All zeros, all zeros. Now byte 2 and 3 I will represent here. This is a 2 bytes I am taking. Byte 3 and byte 4. And I want now 1, 2, 4, 8. 8, 16, 32, 64, 128, 256, 512. Okay. And so on will come here. 1024, something. So you store now your 300. 300 means how much you want? 300, calculate. I think you need 256 for 300. 256 and 300 minus 256, guys. 10 minus 4, 6 means 4. Then how much is there? 9 minus 5 means 4. 44 required still. 44 means how to make 44 now? 44 means you make 132. 32. 32 means this is 2 and 1. You need a 12. 12 means I can take 8. 8 means I got a 4. Still I have 4. So 4 plus 8 plus 32 plus what else? 256. Am I right? 4 bits, just 4 bits. Write this value. 0, 0, 1, 1, 0, 1, 0, 0. How many bits you got as of now? How many bits I represented as of now? How many bits? Bits, numbers, 8 bits, right? Means the first room full, right? First room full or not, guys? This room is full, I think. First room full. Room is full. Next we need the 256, right? 4 bits. This is the 256 we want. So here is the 1 and remaining are zeros only. 0, 0, 0, 0, 0, 0, 0, 1. In this room I have 1 bit. Second room I have 1 bit. These are all remaining zeros only. This is how I store data. In my integer, int a equals to 300. Int a equals to 300. That I stored internally in my 4 bits space like this. 4 bits means I divided this my space into 4 rooms. In this room all zeros, all zeros. In this only 1 bit is there. Remaining here I am using. Okay. Now what I am doing, I am asking, I want to convert this to the byte. Byte B. For B, how many rooms you will get, guys? You will get only 1 room of 8-bit space. 8 bits only you will get. Now dump the data. Dump the data 0, 0, 1, 1, 0, 1. You will get only this much, I think, right? You will get only this much. Now what is the byte value? You are missing 1 bit. This 1 bit you can't get, right? This 1 bit you can't get, guys. You will miss that. But the 1 bit value is 256. What's the 1 bit value? You are losing 256. Now what is the byte value? B value when I print what it comes? What is the B value coming here? 44 only. You lost the data, right? You lost it. That's what it is telling. First I want to conversion. See why the compiler is telling like that. This is how, guys. You compile this program once. Just compile. You know the error message. You know error message. Intentionally I want to show this. It is very clearly telling, boss, these are incompatible. Possible lossy conversion from into type. Compiler is telling clearly, when you convert into to byte, there is a data loss chance is there. Please take care. If you really okay, then only do conversion. I'm doing conversion. If I say do it, compiler will not say any objection. It will do conversion. Compiler, no objection. Now you run this program. When you are running the program, JVM, when running it, it can't bring your 1-bit data, so you lose that. Your byte value is now. So clear the data loss example. So possible loss, not all. Two scenarios I told. Int A equals 65, there is no loss when you convert. But when higher to lower, there is chance of loss of data, guys. Very good. Come back to next lab. 96. We have seen similar lab previously, but previous lab discussed this lab, but now we have to apply the current skills to the previous lab. Okay. 96. Byte B1 equals to 10. Byte B2 equals to 20. Byte B3 equals to B1 plus B2. Super easy. This lab is same lab we discussed, I think, already. But again, I am writing intentionally. Tell me what happens when I compile this program. Will it compile or not? Error will come, right? Compile time error, because the reasons are so clear. You are doing arithmetic operation between byte and byte. So byte plus byte result will come as integer. So result of expression is integer, right? This is an integer. Integer you are assigning to byte. So problem. We know that. We've seen many times. So compile time error has to come. What's the error? Incompatible types, possible lossy conversion from int to byte not allowed. It is telling like that. Okay. Ask again. We've seen this error many times. Again, I am showing you 96. Incompatible types, possible lossy conversion from int to byte. So what to do now? For me, okay, guys, let the data, if any, in this, I know data loss will not happen because my values are 10, 20, 30 only. I can store 30 in byte. So I want to explicitly do conversion. Tell me what I have to do. Is this the way to convert? See what I write in the bracket? Explicit casting I am doing, guys. What I write in the parentheses? You write a byte. It is fine. It is fine. Simple, right? Listen carefully, see carefully, see carefully, see carefully, see carefully. After a typecasting also giving error, guys. I really wondered why it is giving error after typecasting also. Do you have any clue on this? First, analyze the reason for the error. Solution you can tell next. Why error is giving is important. Byte B3 replacement is secondary, Bono. I don't want to byte. I want byte only. B3 integer only. That is a different solution. I want byte only, Banu. Ah, very good. Ponam, you're right. Ponam is right. See, I asked the reason, guys. I'm not asking solutions first. I'm asking reason for the error. My question to you guys. Pavani also has written correctly. Yes. I am asking why this line is giving error. Even I am doing typecasting. What is happening here? You know the importance of operator precedence, right? In the operator precedence, which one will take a highest priority? Which one will take highest priority, guys? Parenthesis. So what is happening here is, you return a byte and B1 plus B2. First, this byte B1. What is a B1? Is a byte. B1 byte is again converting to byte. So result is coming as a byte. After that, it is doing operation with the byte. Again, final result coming as integer. Again, integer assigning to the byte. That's what giving error. But which one you have to convert? You want to convert B1 to byte? No. You want to convert the whole result to the byte. First, you have to evaluate the whole expression. First, evaluate the expression. After getting the final result, the result integer has to be converted to the byte. So, just parenthesis magic. What to do is, give parenthesis for the B1 also. So, this line I am keeping error as it is. I'll give this error lines as it is. If I give this line giving error, this line also giving error, now the correction we are doing. You don't do the B1 to byte. First do the B1 plus byte, B1 plus B2. So this I given as a parenthesis. When I give B1 plus B2 in a parenthesis, first B1 plus B2 operation will happen. Result will come. Result type is integer. The result integer now will be converted to byte, will be assigned to byte B3. Is that clear? Now compiler happy, guys. You got as that. Okay. Next. 97. I have a boolean B1. Boolean B1, boolean B equals to 1. What do you say about this line, guys? Boolean B equals to 1. String str equals to 99. Int x equals to JLC. With the assignment operator, what happens to these lines? You tell me. What happens to these lines? 3 lines. Is that okay? I am thinking all are okay. What do you say then? I am thinking all are okay. All are errors, right? Can I assign the integer to Boolean? What error you are expecting? Will it give an error? Incompatible types, okay. Incompatible types, very good. But will it give any error like possible lossy conversion like that? It will say harshly, int cannot be converted to Boolean. And in this case, int cannot be converted to string. Third case, string cannot be converted to integer. Listen from compiler only, how it will talk to you. 97. Incompatible types, are you counting? I think more than 50 times already completed. We have seen the incompatible more than 50 times as of now. Say this error message. Int cannot be converted to Boolean. Next. Int cannot be converted to string. String cannot be converted to int. If it is giving incompatible message very strongly that you cannot convert, can I do typecasting? Can I do typecasting? 97 is this. 98. Can I do typecasting to avoid this error message like what you done previously? If I want to do, how to do it? In parentheses, what I would write? Tell me here. In parentheses, what I would write? One is integer. Integer, you want to convert it to Boolean. So in parentheses, what I would write? I would write Boolean. This 99 is integer. Integer where you want to convert? To string. In parents, I am writing string conversion. Jails is a string. Where you want to convert? To integer, to a sign. I am doing typecasting, guys. So can you guess the compiler response now? What compiler can tell you? Say something quickly. Even though compiler is telling you can't convert this, you can't convert this, you can't convert this, you are doing typecasting. What can happen? You have seen the previous error messages very clearly. Int cannot be converted to Boolean. Again, you are trying to convert into Boolean. Okay, guys. 98, you see now. 98. Keep 97 errors there only. Previously, compiler told int cannot be converted to Boolean. Again, you are asking, please convert into Boolean. Already told I can't convert this. Previously, int cannot be converted to string. Already compiler told clearly, a integer cannot be converted to string. Again, you are asking, please convert integer to string. How it will convert? String cannot be converted to int. Already told the same message. Again, you are asking, convert string to integer, not possible. So, we have seen three families, numbers, strings, and Boolean. These direct assignments not possible, guys. And also explicit typecasting also not possible. Understand? Explicit typecasting also not possible. Is that clear about assignment operator, typecasting, conversions, all that? Okay, guys. Remaining we'll see in the next session. Remaining we'll see in the next session.